Today we will take a look at a very small program, a very basic program which most of the students write in their junior years. That is the factorial program. So what is basically a factorial? So factorial is any number divided by its n minus 1. So here we would consider the fact that if a given number factorial, see if you have to find the factorial of 4. So how do you find a factorial of 4? So you have to do n minus 1 until you reach 0 and multiply with those numbers. So 4 into n minus 1. So currently the value of n is 4. So n minus 1 is 3. So multiply it with 3. Then also once more you have to do minus 1. So then it will be 1. So likewise 4 into 3, 12 into 1, 12 only. So likewise you have to find the factorial. So that's a recursive approach which I spoke about in general. But in this basic program we use something called as iterative approach. So let's check out the code. So first and foremost important thing is studio.h. The studio.h is the standard input output header file for any C program. Then we have ponyo.h which is the console input output. Functions like clear screen, getch are a part of this header file. Okay, and studio.h has functions like printf, scanf, and all the standard input output stuff. All comes under the studio.h. So then we have integer main. So what we have to remember here is whenever you have a return type here, see I have written an integer main, int main. So my last statement should be a return statement before closing the curly braces. See, I have returned 0. Okay, so there should be a return statement compulsorily, or else you would have an error there as you have not returned anything. So then we initialize all our variables. I is for the iteration, n is for the number, and f is the variable which stores the final result, that is the factorial of the number. So in the first line we have to display a message, enter number. So we display it using printf function, and inside the printf function you will see a backslash n. A backslash n is a new line. So whenever a line completes, you should use backslash n to get to the next line. You can also use backslash c to do the carriage return. Okay, so after backslash n you can also write backslash c so that it gives the proper alignment, but that's not really necessary. But if you want, you can do it. Then we read the variable, okay, the value of n. So for that purpose we need scanf. So scanf %d. %d is the format specifier. Okay, format specifier tells us the type of data that is being referenced, because all the data here, see, percent ampersand n they have written here. Okay, so ampersand n means the value at the address of that location. Sorry, it's not the value but the address of n. So this does pass the value by reference. So you have to specify the format, or a garbage value might be written to this space, because C doesn't know what kind of data is to be written here. Okay, so if you misplace the format specifier, you would get unpredictable results, or in other words you can say garbage value. So now the main loop. Okay, so for I equals to 1 to I less than equals to n. So remember the I should always start with 1. Here previously I initialized with 0, but when I am about to start the loop I need to start or initialize I with 1. If I initialize the I with 0 here, my result will be 0, because inside the loop I have written the condition f is equals to f into I. Previously I have assigned f equals to 1. So if I assign 0 to I, in the first iteration itself the value will be 0, and so forth. Until the end it will be 0 only, no matter how many incrementations I take. 0 into 0 is always 0. So either way, So to begin with, I have to start the iteration with I equals to 1. So here f is equals to f into I. So when I start my loop, so if I want to take the factorial of 4, my loop would always begin with 1 because we have to stop before 0 as I said previously. So I start with 1. So I want to take the factorial of 4. Okay. So f is equals to 1 in the first stage. Okay. And I is also 1. So 1 into 1 is 1. Now value of f is 1 again. Okay. So now I is incremented here. So now I is 2. And f is previously 1. So 1 into 2 is 2. Now f is 2. Okay. Then we have comes I becomes 3. Okay. So 2 into 3 is 6. Okay. And 4 into 6 now is 24. Okay. So now comes 5. But our loop is less than or equals to n, and we have entered n as 4. Okay. So loop terminates here. Okay. This is the boundary condition of our loop. So our final output was 4 6 are 24. So we directly display the message printf factorial of %d is %f. So first %d, here we display the number, the original number n, and %d, the second %d, we display the factorial f, and then we write get ch to wait for some time before the prompt returns, and finally we write return 0. Return 0, generally whenever your program executes without an error, you have to return 0, and if there are any errors or any kind of exceptions that might occur, then you can return any non-zero integer. Okay, so that's a general case, so remember it. Okay, thank you.